Hello students, in this video we'll discuss about how to construct the Turing machines for a language. So in the last video we have discussed the Turing machine, introduction to Turing machine, and the tuple notation, and the computations, and Turing church hypothesis, right? So let me go with one language, right? Turing machine for a language A power n, B power n. See guys, here we are going to have the tape, right, which moves in bidirectional. What is this language? Number of A's followed by equal number of B's. Like that you might be having in this way. So A, B, 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 and the end of the symbol is denoted with delta. Okay, assume that we are having like this. Now we want to prove that here the number of A's are equivalent to number of B's without counting them. Counting is not possible. So measures are not possible here. So assume that you are a person here. You can move from left to right and right to left, but at the end you should prove that the number of A's are equivalent to number of B's. Counting is not allowed here in this case. Then how can we do this? Let me give an approach here how to do it. First, for every A you have to find one B, right? So that number of A's followed by equal number of B's. What I'm doing here, if it is A, I'm changing it to X and searching for the B. If it is B, changing it to Y, then again we have to go for the second A, right? But how I know that there is a second A? When you are going left side after making the B as Y, when you are going left side, if A comes, that may or may not be the next A to be considered. Then what you have to do? You have to search for X, right? If X comes, then go right side, that is the next A. Repeat the process. Change this A to X and search for the B. So while you are going to the B, you may get anything, but don't do anything. Just if it is B, change it to Y. Then again, what you are supposed to do after changing B to Y, you have to go with the next A to be considered. So again, how I get that the next A means the A immediately after the X is the next A. So while you are going back, search for X. Then you may get Y, don't change it. You may get A, don't do it. If search for X. Then if it is X, just simply come right side, you'll find A, change it to X. Then find for B, Y. We know that whether the A's are left or not, then again you search for the X. After X, if it is Y, that means number of A's are done. Then ensure that there are no B's also. This is approach. Okay, let me explain with a string, don't worry. Now same, assume that I'm not going to write the tape here, but everything I'm going to represent just to tell you that the movements, I just explained that. Let me go with this guys. See, assume that I'm having 4 A's and 4 B's. Then what could be the approach to do it? The end of the string is denoted with the delta. Now first and the foremost thing is you have to change 1A to X. So for that I'm going with some states like Q. Okay, then what I'm doing the task to the Q here. If it is A, right, Q naught, you can take it, Q naught A, then change this A to X and after that go for right side. Go for what? Right side. Then whether we have to change the state or not. Yes. What will be happen if you will be in the same state? Q naught. What is the task assigned to the Q naught? If it is A, change to X, go on right side. If I won't change the state, it will make every A to X. That's the reason you must change the state to Q1. Then Q1, what it will do, it will search for B. That is its task. So Q1, after changing A to X, we are giving the task to Q1. Q1A, don't do anything, just keep on right side. Q1A, don't do anything, keep on right side. Q1A, don't do anything, keep on right side. Q1B. So Q1 was intended to search for B, then it got the B. Then if it is B, change it to Y and after that move left side and hand over the task to Q2. So change the B to Y and move the left side. Okay, then what will be happen here? So here we are having X, A, Y, B, delta. Then the task is given to Q naught. Sorry, Q2. Q2. Now in reverse you have to search for what? Not for A, because we have to change the second A to X. But how I know that that is the next A to be considered means the A which is immediately after the X is nothing but the next A. So in the reverse Q2 was searching for X in left direction. Searching for what? X. So if it is A, don't do anything. If it is A, don't do anything. Q2 just keep on moving left side if it is A. And if it is X, then what you are supposed to do, why we got the X here, so just simply to find the A, Y, B, delta. Then if it is Q, when you are giving the task, Q2 got the X. If it is X, don't do anything, simply move right side, and we have to do like this, means we are just moving right side. That's it, we are not doing anything with X. Why we found it? Just to find the next A. Then if it is A, what we have to do again, we have to repeat A, change A to X. Whose task it is? Q naught. Then assign it to Q naught iteratively. So Q naught AX change to right. Then Q1 search for the B. Well, it is searching for the B, it may get A, don't do anything, it may get A, don't do anything, it may get Y, don't do anything, it may get B, change it to Y. And assign the task to Q2. Same, whatever the repeated task we have given. So X, A, Y, B, delta. Then same way the task is given to Q2. While it is searching for the X after making the BS, then it may encounter Y, don't do anything. Move on left side, encounter A, don't do anything, move on left side, encounter X. Then we found the X just to find the A. That's why I'm giving the task to Q naught. Y, B, delta. And the task is given to X. Sorry, Q naught. If it is A, change it to X and give the task to Q1. Q1 A, don't do anything, just move on right side until it finds a B. Q1 B, change it to Y, give the task to Q2. Q2 finds. Like that we have to repeat it. So then when Q0 encounters say like that, all the A's change to X, assume that, and all the B's change to Y. The last B changed to Y and it search for the X. And we are giving the task to Q0. Let search X, or we are giving the task to Q0. But Q0 encounters Y. Means what? Don't do anything, move on right side and give the task to Q3. Because if Q0 encounters A, you can change X to X and we can. But if it is Y, means no A's are in the string. Then what we can do, give the task to Q3, search for delta. Right? Because we should not have B's till delta. Then what you have to do, if it is delta, don't do anything, no need to move anywhere, simply you can accept it. That's it, you don't need to do anything. So how we are going to specify it as a Turing machine? We have 5 states here, right? Let me draw the diagram. So first Q0 is giving task to whom? Q1. When it is giving, and also it is giving task to Q3. When it is giving, if it is A, change it to X and right direction, giving to Q1. Just mention it. See? Then Q1 is giving task to whom? Q2. When it is giving, if it is B, change it to Y, left direction. Just whatever we have written. And Q2 is giving task to whom? Q0. When it is giving, if it is X, right side. That's it. And Q3, when Q0 is giving task to Q3, if it is Y, don't do anything, just move on right side. And Q3 is searching for delta. So delta, no movement, you can accept it. That's how it is going to be. But see, these are the only basic things. Q0 is not searching for anything, but Q1 is searching for B. While it is searching for the B, what are the possibilities it may encounter? See, after making the second A as X, Q1 is searching for the second B. It may encounter A and Y. So we are not doing anything, just you have to specify such. While the Q1 is searching for the B, it may encounter A, don't do anything, just keep on right side. It may encounter Y also, don't do anything, just keep on right side. That's what you have to tell it. What you have to do if it is encounters other than B. Then Q2 is searching for the X after making the B as Y. It was searching for the X. While it was searching for the X, what are the possibilities? It may get Y, A. So you have to mention the Q2 that you may get A, don't do anything, just keep on left side. You may get Y's, don't do anything, just keep on left side. Other than this, we can say that the string is not in A power n, B power n. Q3. If there are no A's, then we have to search for the delta. Until delta, you should get only Y, Y, R. Other than that, then that is not. So this is the Turing machine. See this. That's how it is going to be. Here the blank symbol is represented with the capital B. Let me explain for the A power n, B power n. How we have to do it. Guys, listen here please. See same up thing here. A, B, 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 C, C, C. Then change A to X, B to Y, C to Z. Don't expect me to tell like earlier. A to X, search for B. B to Y, search for C. C to Z, search for X. And A to X, search for B. B to Y, search for C. C to Z, search for X. Do it. Then you can write it. Same thing. See Q0, you can draw it directly. If it is A, change it to X, move on right side, give the task to Q1. And Q1 is searching for B. If it is B, change it to Y, move on right side because we have to search for C. Q2 is searching for C. So if it is C, right? If it is C, change it to Z and left direction we have to give the task to Q3. Now Q3 was searching for X after making the C to Z. Then whenever it gets a X, give the task to Q0. Same task has to be repeated. Then after X, if it is Y, then give the task to Q4. And Q4 has to search for delta. If it is delta, delta, no movement, you can accept it. The task is not this. The task is what are the possibilities? Q0 may encounter either A or Y only. Q1 was searching for B. After making the second A to X, when you are searching for the second B, it may encounter A and B. Then don't do anything. Just A, left side, right side, Y, right side. Keep on moving. And while making the second B to Y and searching for the second C, it may get B and Z. Don't do anything. Just keep on moving. B right side, Z right side. After making the second C as Z, when you are searching for the X, you may get the first Z. Move on left side. B you may get it. Move on left side. Y you may get it. Move on left side. A you may get it. Move on left side. If it is X, you can hand over the task to Q0. And Q4 was searching for delta. While it is searching for delta, you may get YYR and of course ZZR also. If you want to change the state, that's your wish, but you can do this. So this is the Turing machine for A power n, B power n, C power n. Like that, you can construct. See, this is not CFL, guys. A power n, B power n, C power n. We proved that this is not CFL by using the pumping lemma of context-free languages. A power I, B power I, C power I. You might have remembered it. So like which is even not CFL can be recognized by the Turing machine. Like see here, same thing, whatever we have done, just we have taken here, right? C, Z, everything. Okay, this is how we are going to construct the Turing machine. See, the Turing machine is not only intended to perform the language acceptance, even we can perform the computations like one's complement, two's complement, addition, subtraction. As I told you, whatever the task done by the computer can also be done by the Turing machine. So we have so many other, so that we will discuss in the next video, computational languages and functions.